Hello and welcome to recording 1E in our review series on angles in standard position, Unit 2, Chapter 2, Trigonometry, Mathematics 2200. In this recording, we'll be focusing on a couple of examples to extend our understanding of problem solving involving 30, 60, 90, and 45, 45, 90 triangles. In this first example, we're asked for the value of x in this diagram. To do that, we're going to need to find this full side of the large triangle and subtract from it this short piece. So we need to work on using the two triangles. Since the problem is based on 45, 45, 90 triangles, at some point we're going to need to work with that base triangle that we learned about in one of the instructional clips. So 45 goes right here, 1 root 2. Notice I'm not really drawing everything to scale. This triangle really should have been smaller than even the smaller triangle in the problem. Okay, let's also begin by drawing the two triangles in the problem outside of each other. Okay, so I have the two triangles sketched. I'll call the lower side of the large triangle, I'll call that A. Let's work on finding A. Cosine of 45 degrees from that triangle is A over 14 root 2. Meanwhile, from our base triangle, the cosine of 45 degrees is 1 over root 2. So we'll make 1 over root 2 equal to A over 14 root 2. Put a cross multiplication, A root 2 equals 14 root 2. We divide both sides by root 2 to get A equals 14. So just divided by root 2 there. And in the second diagram, we have to find this little length B, I'll call it. So we have cosine of 45 in that diagram equals B over 4 root 2. Let's move that over a little bit because it's a little almost off the screen there. There we go. So like before, we make our ratio from our base triangle equal to B over 4 root 2. A little bit of cross multiplication. We get 4 root 2 equals B root 2. Divide by root 2, we get 4 equals B. Therefore, after all is said and done, the value of x will equal the 14 that we found for the large side of the triangle and subtract the 4 we found for this side of the small triangle. 10 minus 4, 14 minus 4 rather, will give us 10. Now, this next example involves the use of both special triangles. Therefore, at some point, we are going to need our base triangles, the 45, 45, 90, and the 30, 60, 90. So, taking a close look at this diagram, we realize that this is not a right triangle in and of itself. However, we can section it up into two right triangles. One of them being 45, 45, 90, and the other one being 30, 60, 90. We have to find the exact distance from A to B. So we're going to do that in stages. We're going to find the value of x right here, I'll call it, and the value of y right here. Notice how I've oriented my two basic triangles the same way they are oriented in the diagram. Makes it a little easier to visualize stuff. For our 45, 45, 90 triangle here, I'll choose cosine because x is my adjacent side. So it's x over root 30. And From my base triangle, the cosine of 45 degrees is 1 over root 2. So I've got 1 over root 2 equals x over root 30. So I've got x root 2 equals root 30 when I do a little bit of cross multiplication. And I've got to divide both sides here by the root 2 to get root 15 for the value of x. So we now know x is root 15. Meanwhile, we want to work with the other triangle as well to get the value of y, but we don't have another side measurement to work with, or do we? Recall that the 45, 45, 90 triangle is isosceles, so that means that this altitude here also had to be root 15, which is also a side of the 30, 60, 90 triangle. So using a bit of trigonometry here, root 15 is our opposite, y is our adjacent, so tan we'll have to use for this one. Tan of 30 degrees equals root 15 over y. From our base triangle, the tan of 30 degrees is root 3 over 1, or just root 3. So we've got root 3 equals root 15 over y. Y root 3, therefore, when we cross multiply, is equal to root 15. We divide both sides by root 3. And it turns out that y is equal to root 5. Therefore, from A to B, the distance is root 15 plus root 5 units, whatever those units happen to be. And we're done. As a quick conclusion, the exact trigonometric ratios for 30, 45, and 60 can be used to determine the exact side lengths in triangles involving these angles. Just be sure to choose the appropriate triangle for the problem.